So I think that it's really important in any design considerations, whether it's engineering or science, that we are able, as much as possible, to measure what we're trying to improve. And I think that we need to start doing that more rigorously for energy efficiency. We've been doing it for performance for years, but we have not been doing it for energy efficiency. And that's what I'm working on. But I must say that it's easier said than done. So let me give you a little bit of background. I actually am the chair of an energy efficient high performance computing working group. We're an ad hoc group. You're all welcome to join. We have about 250 members, 16 different countries. And we basically focus on whatever key people, it's all volunteer kinds of thing. It's all passionate people about, people that are passionate about HPC and energy efficiency. We have a peer-to-peer exchange, best practices and case studies, and collective action. So we work together to try and move the whole community. And there's some links in terms of how you might contact us. I'd be glad to talk to anybody offline and take your card and sign you up as well. So what am I going to talk about? Apples to apples measurements, flops per watt. Let's see, did everybody get it? What's in the watt? What's in the what? My daughter said that I should become a nerd comedian. I don't really think so, but it is my first nerd joke. So I'm going to talk about that, and then I'm going to talk about refining PUE with TUE. Is there anyone here who has heard of PUE? Okay, that's almost everybody. That's good, because I wasn't going to go into it, but I am going to talk about TUE. And then moving beyond the one, does everybody know what that might mean? Okay, many fewer people. So we're basically at one with PUE. We started out at about 2, and we're down to pretty close to 1. And so what do we need to do beyond that? And I'm going to talk about energy reuse and carbon. So one of the things that I'm doing, I have a collaboration going with the Top 500, the Green 500, the Green Grid, and the EEHPC working group. And the Green Grid, probably not that many people have heard of the Green Grid. I'm wearing their t-shirt. The Green Grid is an enterprise-focused organization. All the vendors and a lot of the big enterprise solution providers all get together and talk about how they can improve energy efficiency of the data center. And they're doing a lot of really good work. They're the ones who came up with PUE, TUE, and CUE, and WUE, and the whole family of UEs. But they're really important. They have a lot of money, and they make a difference in the industry, and so it's important for HPC, which is a fairly minor player, to work with the Green Grid, and that's why I include them. Our goal in this particular collaboration is to evaluate and improve methodology metrics and drive towards convergence on workloads, so for energy efficiency. To form a basis for evaluating energy efficiency of individual architectures and vendors, so this is very focused on the kinds of work that the Green 500 and the Top 500 do. This is not so much for energy efficiency of your particular data center. We're doing things like that too, but in other kinds of efforts. Again, target architecture design and the procurement decision-making process. So what's our assumption in terms of workloads? Well, our assumption is the energy efficiency high-performance computing working group doesn't have the time or the bandwidth to decide on workloads. We're going to leverage well-established workloads. We're going to exercise the HPC system to the fullest capability possible, and that exercise is in the energy domain, right? So we want big power draw. We're going to measure the behavior of key system components, so no one benchmark will do it all. No one workload will do it all. So we're going to break it down into multiple problems. We're going to focus on different subsystems. the compute, memory, interconnect, storage, and external I/O, and we're going to phase that over time. Our first focus is on the compute subsystem using HPL, high performance LINPACK, for exercising system. It does exercise some of the other subsystems, which you guys probably know better than I do, but it's primarily a compute subsystem. Stress, we're talking about, and we'll probably use random access for exercising the memory subsystem, and we need to identify workloads for the other subsystems over time. Okay, flops per watt. So what's in the watt? It's very difficult today. We don't have a very rigorous methodology for measuring watts. There are fuzzy lines between the computer system and the data center, like fans and cooling systems. Shared resources are hard to measure, like storage and networking. The data center is not really instrumented for computer system level measurement. How many people here have the ability to measure the power of each one of your systems on the floor? Yeah, that's great. I'm glad to see the numbers, but I'm not surprised. It's probably around 17% or something like that of the people in the room. It's just not there. The capability is not there for us to do system level measurements very easily. Then the measurement tool limitations, things like frequency and power versus energy, are also factors that are difficult to get apples to apples comparisons with. There are some people who want to drive DC system level measurements, but that doesn't include power supply losses, so that's a big problem that we're going to need to figure out how to manage. So we have been working we've come up with a proposed improvement in the power system, the power measurement methodology. That is a compromise between being very flexible, so everybody can measure their power, and being rigorous. And what we've proposed is 3 levels of measurement quality. So they'll be based on the lowest level is, basically what the Green 500 requires today, and the highest level is based on what the most rigorous power measurement capabilities that exist today. It's a current best practice. We're looking at places like Lawrence Livermore National Lab, what helped us to set the current best in terms of capability for making power measurements. But there are other people that have the same capability that Lawrence Livermore does. So it's things like sampling rate, the completeness of what's being measured, common rules for start and stop times, and the vision is over time to continuously raise that bar so that, we're at the current best over time as well. So just real quickly, the level 1, 20% of the run would be measured during the core phase of HPL. And you'd only have to report 1 power measurement. It'd just be an average power measurement. And 1/64th of the machine, so you could extrapolate from 1/64th of the machine to the entire machine's power. That's basically what's the Green 500 today. Level 3 is the most rigorous one that we're defining. It's 100% of the run. It's an integrated energy measurement, not a series of average power measurements. We're currently talking about 10 running total energy measurements. From an audit perspective, you'd report 10 measurements, and it'd be the whole machine. Now, right now, we just have the list in all 3 categories, just the list. Tell us what you measured. So we're not prescriptive on what has to be measured. That's probably something that we're going to change. We are in the early adopter phase, so we have 5 people testing this proposed methodology. We have Lawrence Livermore National Lab, Leibniz Supercomputing Center, Oak Ridge National Lab, Argonne National Lab, and Université Laval, Calcul Québec, Compute Canada, all the same organization. That represents 3 different vendors, and We're seeking feedback from these early adopters, and I'll tell you in a minute, we have a BOF actually on Tuesday where they'll be reporting their results. We also have the Green Grid. All the different vendor communities associated with the Green Grid are reviewing our document, actually have reviewed our document and given us feedback. And then we also are welcoming feedback from the community. We have been participating in BOFs at both SC and ISC as we've been going through this process, and we're looking for active feedback from the community. The next revision will be expected by September 2012. I already know that there will be changes in it based on the feedback we got from the early adopters. And the reason I say September is because it'll be used for, my fingers are crossed, but I'm hoping we actually deploy this, implement it as part of the November lists for the Top 500 and the Green 500. So there's the BOF information, and the people that'll be there reporting are Kim Cups, Herbert Huber, and Susan Coughlin, as well as Eric Strohmeyer, myself, and Nick Dubé from the Green Grid. Oh, Wu Feng would have been there from the Green 500, but his plane got canceled, so he's not going to make it. Okay, now let's talk about PUE. Okay, so this is PUE, which is basically total energy over IT energy. It's cooling, power distribution, miscellaneous things like lighting, and your IT over IT, right? So it's never less than 1 because it's IT over IT plus all the rest of the stuff. Problem, PUE, and this is actually most apparent in high-performance computing. PUE doesn't account for cooling and power distribution losses inside the compute subsystem, or the compute system. So we're coming up, the EEHPC working group has a proposal. We've actually written a paper on this, and hopefully we'll be able to present it at supercomputing, where we want to capture support inefficiencies in the fans, liquid cooling, power supplies, et cetera, that's oftentimes included in the IT equipment. It'll be a better ratio of total energy. And also, if you are going to use it for inter-site comparison, it'll make a better comparison. So just to give an example, because IT is in the numerator and the denominator, if you have only IT fans, your PUE is going to be lowest. If you have only building fans, your PUE will be highest, which is bad. High PUE is bad. And then a medium case is where you have both building and IT fans. So what we're talking about is the boxed-in area is the new material, is basically defining the, taking out the components, the fans, power supplies, voltage regulators, et cetera, taking them out of the IT section, the numerator, and putting it all into the denominator. Okay, so that will take us a step further. This is a peeling the onion kind of exercise. So the CPU, GPU, memory controllers mix, they're all IT. And fans, pumps, PSUs, and voltage regulators are all infrastructure. That's really good. But what about disk drives, status lights, and baseboard controllers, and a host of other things? So again, this is a peeling the onion kind of problem, but it is a step in the right direction. Okay, beyond the 1.0. So we started out, when we first defined PUE, the average PUE was around 2. It still is around 2, actually, for most data centers because legacy. People just can't get rid of you can't totally redesign your data center, and or you don't want to, and get it probably beyond about 1.5. You can redefine it and get it around 1.5. In fact, best practices in terms of airflow management and those kinds of things can give you a PUE of about 1.5. And if there's anybody who wants information on how to improve the energy efficiency of their data center, we do have some resources that can help you in that regard. Beyond 1.5, you can get there for things like free cooling. And a lot of centers are very close to 1.0, including the Leibniz Supercomputing Center and in the US, the National Renewable Energy Lab. So I'm reusing waste heat from my data center in another part of my site, and my PUE is 0.8. Not allowed, right? PUE can never be less than 1. Okay, but we have defined a new metric, which is energy reuse effectiveness. It's the total energy minus the reused energy over IT energy. It's a great idea. I'd love to see people actually try and use it and people start publishing it. So far, I haven't found anybody who's doing that. I think NREL will probably be the first person. They have actually written a white paper and helped to define this. But if there's other people who are interested, who have a data center that's, is there anybody here who's doing heat reuse? Great. Are you from Swiss? Swiss, and where you come? Swiss? Okay, great. Yeah, Fraunhofer too. Great. Perfect. I think actually Europe is leading in this regard. I think that there's more energy reuse going on in Europe than anywhere else in the world. Thank you very much. I'd like to talk to you guys actually about publishing this and, you know, highlighting it. Let's bring it to SC. Let's talk about it. Let's make sure the rest of the world gives, you know, starts recognizing what you're doing here. So if we were to do this, maybe we could get away from the focus on PUE or start looking at PUE and ERE together. So, you know, the list would be reordered if we were to start looking at this capability, this metric. And then carbon usage effectiveness. So how many people here are running entirely on renewable energy? Good. Where are you from? Okay, great. Wow. What kind of energy are you using?
In Germany, you can buy renewable energy. So you can buy your electricity and say you only want renewable energy. And this is what the German climate computer said here in Hamburg.
Oh, fantastic. That's great. Well, so I actually was, I was able to visit Iceland and help them with the inauguration of a Nordic HPC data center in Iceland. Is there anybody here who's part of the Nordic HPC data center? No? Anyway. Norway, Sweden, Denmark, and Iceland collaborating. They've built a data center. Well, they've installed a system. It's actually a cluster. It wouldn't even make the top 500 list, but it's a first step. They've installed a cluster in Iceland. So, and they're using entirely geothermal and hydroelectric power, mostly geothermal to drive it. They do have a diesel generator backup, actually a huge honker diesel generator backup. So their CUE would not be 0, but it's very good. So they are using a lot of renewable energy. They also are using free cooling, so their PUE is low to begin with. And the power there, by the way, is about 3 cents a kilowatt hour. So it's an order of magnitude cheaper than it is in Norway. That's another reason that they're there. But anyway, if we can do things like siting our data centers where there's, you know, renewable energy, especially cheap renewable energy, I think that we'll all be better off. So that's it. Any questions? Yeah. Yeah.
You have free energy to produce this stuff. So what is your...
So my personal take, yeah. So, by the way, I worked for Intel for 20 years.
Using energy, however, sometimes it's more green than actually for the
Yeah. Yeah, it is. I think you bring up a really good point, and you know, I'd like to see us look to cradle to grave costs, right? So that they are personally, so that we actually bear all those costs. I'd like to be able to see something. The ex-CTO of Sun, Greg Papadopoulos, has written a really pretty good book in this regard on designing up front for reusability, recyclability, you know, even of computer systems. So, yeah, I totally agree with you. We need to, that's another direction we need to go. And in fact, tomorrow's session, HPC energy efficiency at what cost, Nick Dubé will be talking, and he'll talk about the NetZ data center, and that's one of his ideas in there too. So he'll mention it, I'm sure. Yeah, I think we have another question. Yeah. Yeah, I have somebody from who's really a key on that, who's been talking to me for a while, Jim Laros from Sandia National Lab. And so I've been trying to put together a team that'll actually help to drive the APIs that would allow us to get access, better access to those capabilities. I think that there are things that Intel is providing today that you can only get under NDA, and you know, only if you're special, you know, but they should be generally available. And it's not just Intel. I mean, we need to actually drive the vendor community to put the hooks in place for the other circuits and, you know, things, so that we can actually measure the power, so that we can put the power management tools in place. Yeah. So if you want to join our group and join that team, I'd be glad to help participate.